Welcome everyone to the Running Robots Senior Design Showcase for the School of Computing. First off, I want to thank our sponsor, Christopher Bohn, for letting us work on this project and being able to work and develop and being able to improve upon it. I also want to thank our project manager and our tribe leads, Roland, Jeffrey, and Juan. Thank you for supporting us and helping us along the way. A brief introduction into our team. Hello, my name is Ben Fritz. I was the project manager along this team. Our development manager was Gage Hasbrook. And then on to our student team. These are our developers that worked along with the team. We had Treggy Seebeck. This is Cade Maley. We had Avery Munson, and then we had John McLean. So kind of an overview of the Running Robot project. Often, games that use some sort of robotics are not easily replicable or able to be easily upgraded and modified. So we kind of wanted to create a way for first-time robot enthusiasts and kind of high school clubs or early level college classes to be able to create a way to easily be able to assemble these robots and be able to get hands-on experience with hardware, 3D printing, coding, wire management, and kind of everything hands-on instead of just being taught it in front of a lecture. So our product solution was to create 2 tanks that are run using a Raspberry Pi. This allows them to control the motor of the treads. It allows them to access a live camera feed. They use a IR emitter and an IR receiver to be able to send and receive hits. We created a web application that has different game modes, such as laser tag, capture the flag, and target practice. And we also allowed it for the web app to be hosted on Neuros, so you're actually able to access through the UNL Wi-Fi instead of needing to run it locally. We also worked on creating mobile apps. Originally, the app, when we received it, just had an Android app, but we wanted to port it over to iOS. So we actually created a way to allow both of them to be able to connect, so you're actually able to use it using either an Android phone or an iPhone. We also wanted to create a way, because laser tag by itself is normally very competitive. We wanted to create a way to allow collaboration into these types of games, so we created a 2-player mode. This allows one person to control the tank and be able to fire the tank. And then we also allowed the other person who is able to turn the turret and actually has the camera feed. This forces some sort of collaboration between the two, actually need to communicate when to fire and where they need to turn. We also wanted to create a way for players to be able to use the game by themselves. So we created a target practice game mode that allows you, each target is set up with a IR receiver, all run through a Raspberry Pico Pi that sends key presses to a computer to be able to register the time starting. A hit has been registered through IR receiver and the time stopping. Each IR receiver is on a 3D printed tower to allow it to be at the same level as the tanks, and we have an IR gate that allows it to start and stop the game when the tank drives by. So here, as you can see, is our general assembly of our robot tanks. You can see the 3D printed pieces on top. You can see an IR dome to allow an IR signal from all sides. The front is where the IR emitter is, where you can shoot. You can see the treads on both sides. And yeah, so we 3D printed all parts and worked on being able to assemble it easily. And I will pass it over to Kane to kind of explain more in depth of what we worked on.
Yeah, so the robot itself is powered and operated by a Raspberry Pi with a series of Python files. However, in order to power the Raspberry Pi and interpret the many inputs from the parts, such as the aforementioned motors, servos, the turning of the turret, and the IR emitter and receiver, we also had to design a custom PCB, which anyone who has the blueprints could easily replicate for themselves and install the components, which is what you're seeing here. Next, I'm just going to go over some of the simple components of our app and some screenshots of them. This is the current implementation of the web app. It's currently, as we stated before, runs on Neuros, a server run by the university on a website. And this is what you'll see when you immediately log in, being able to start a game, which I'll show one of. This here was the implementation for our target practice game mode. This one allows users to create the game, and you kind of get to see what the image is here is. You get to create one game, and you can select the number of targets, play it, and all of this is operated by key presses, which are controlled by that aforementioned Raspberry Pico Pi. so that once you start up the game, you don't really need to touch the monitor or the computer. You just let it run and play the game through the mobile app. This is a screenshot from our mobile app, particularly the Android development. Because of the architecture we used, being a React Native framework through Expo, this means that the iOS and the Android framework are more or less completely identical in functionality. And this is how it looks. On the far right, you'll be able to see our implementation for the controller of a single player having one joystick, a set of turret controls, and the fire. Next was that two-player mode. On the right side, you'll see the player who is the driver having access to just the controls and the fire. And then on the left, we have the turret control, who gets access to the camera feature, along with being able to turn the turret, designed in such a way that if you can turn it, you can't fire it. So there has to be some form of cooperation. And along with this, each of the tools that were used to create this app are modified so that they can be easily, they're very modular. They can easily be replaced or edited for future users who pick up this app after us. So next, why we did this and some of the value we brought to the project is that we extended an open source platform that anyone could edit that's designed to be modified by future parties who may not be directly associated with us. And it's fairly easy for someone else to set up from scratch or with this set of instructions, along with being competitive and cooperative to be played between friends and members of groups, being able to design to scale upwards, and utilizing servers that can be localized or can also be set up on a remote server like UNL's Neuro server. And just some of the big highlights, something that we really thought were important or that we enjoyed was being able to deploy that new version of the iOS and Android app, because it allows a lot larger base of people to install the app and play it and see what the value is, along with being able just to redesign the turrets themselves. Compared to past years, they are visually identical. However, once you actually get into it, you'll see that the turret designs are also quite different, designed just to last longer and have a better construction, along with designing that new PCB, which allows the Raspberry Pi to function better, and creating the new game modes such as that two-player and the target practice game mode.